This is an interesting problem. I'm not sure where it comes from. It was sent to me. It's rather like Langley's Adventitious angles, but not quite the same. First of all, let's do a brief inspection of the problem. Let's look at the large triangle, and we see we have equal base angles, an isosceles triangle. Let's have a look at another triangle. Again, it has equal base angles, and we have another isosceles triangle. Now we may be able to use these to solve our problem. We'll just have to see. So let's label the vertices. There's a free worksheet you can download from my website. The link is in the description below, so you can do the problem yourself. If you do download the worksheet, the next thing to get hold of is a compass and straight edge. It can be your best friend when trying to solve these kinds of problems. So let's go over to the problem and look at what we can do. First of all, angle BFA is 180 minus 50 minus 30, 100 degrees. So its opposite angle, EFD, will also be 100 degrees. Now we're going to use what we noted earlier. We've got a couple of isosceles triangles in this figure, and one is at ADB because it has equal base angles of 50. Now I'm going to take my compass and construct circle DA. So the point B will fall on the circumference. For the next step, I'm going to extend BE so it touches the circumference and make a new point G. Next step, join D to G. This forms a new isosceles triangle, BDG, with equal base angles of 20 degrees. Now the obtuse angle in the middle of that triangle will be 180 minus 20 minus 20, which is 140 degrees. If we remember that the angle ADB is 80 degrees, then the angle ADG will be 140 minus 80 degrees, which is 60 degrees. Next step, join G to A. I now have two equal sides and an included angle of 60 degrees. That triangle is equilateral. At the point A of our new equilateral triangle, we see we have one angle, DAC, which is 30 degrees. So the other angle, GAC, will also be 30 degrees. Now things are really falling into place, because not only do we have an equilateral triangle, DAG, but one of the sides of our original triangle has become its perpendicular bisector. Now the properties of an equilateral triangle will help us to solve this problem from here. By the perpendicular bisector theorem, DE equals GE, forming another isosceles triangle with equal base angles of 20. Now we see that angle ADG is 60, established, and angle EDG is 20, which we just found. Angle ADE is 40. All it remains is to find the angle FED. We have the other two angles of the triangle. That is, we have 100 and 40. So our final answer is x equals 40 degrees. As I mentioned at the beginning, this problem is similar to, but not the same as, Langley's Adventitious angles, which were published way back in 1922. If you'd like to look at Langley's problems, have a look at my other YouTube videos similar to this one. Thanks for watching.